All right, it's 11 o'clock. We'll get started pretty much right away. Just want to throw out some reminders. Reminder number one: there's no assignment this week. This week is being treated as kind of a makeup week. Make sure that, especially for those of you who have not handed certain assignments in, make sure you get them in. I'll be taking a look at them throughout the week. But if you know you're someone who's gotten everything in, you're all set. The only thing you need to do is pretty much tune in each day to learn the new stuff. Tomorrow, there will be no stream. I'm going up to the school tomorrow. I'm going to try to print out some additional topics for us to learn. Ones that I would not have taught you normally, but ones that I think are going to be useful to you as many of you go to Algebra 2 next year. So I'm going to teach you some stuff that you might even just relearn it next year, but I think it's going to be very useful. So my plan is to print that stuff out so we have it, because I'm not sure when they're doing the next delivery. I'm just being a little proactive, getting it ready as soon as possible, because I know there's plenty to this packet that we have to do. The circles is a huge unit. There's so much to circles. My guess is we're probably halfway through the packet now, and we've been doing this already for like 2 weeks. And I think that's about it. So no stream tomorrow. Also no assignment, but we'll definitely be streaming on Thursday and Friday. All right, we'll get right down to it. We're practicing the segment rules. So actually, before I jump into it, I'll kind of refresh our memory to those segment rules that we see right here. Definitely different than the angle rules. I think the angle rules are a little bit easier because all three of them follow the same pattern. Big arc minus little arc divided by 2. These are a little bit more, I think, trickier in my opinion, especially what we see in Type 2 and Type 3, because you really do need to remember how the line segment is broken up, that you need to use the outside piece times the entire piece, which is a little bit unusual. It'd be a lot easier if it was just A times B equals C times D, but it's not. It's A, and then the entire line segment, and then C, and then the entire line segment. So definitely makes it a little bit trickier for this type. And all three types are also different from each other, where the angle ones weren't really different from each other. This one's even a little bit different, but not much harder. I mean, it still follows the same trend. Outside piece times the entire piece, which is B plus C. But if you have a tangent, you would square the tangent. If you had two tangents, remember we've covered that rule already actually. If you have two tangents from the same point, they would just be congruent to each other. So you don't even have to worry about that. But those are the three rules we're going to be utilizing. So the goal is we're going to try to do as many on this page as possible. And then we'll be done with pretty much those specific rules to circles. And at this point, we've now covered the majority of them, because the next thing is actually something I like a lot, the equation of the circle. We'll probably be looking at that on Thursday and Friday and a little bit next week. All right, let's see. Number 7. So just taking a look at what they gave me. We have this 8, 7, and we have two expressions. We have the 3x plus 4 and this 5x plus 2. Now just be aware that those expressions by themselves that are inside the circle are not 100% useful. We have to do this outside piece, 8, times the entire line segment. So it's the 3x plus 4 plus 8, which we could call the whole thing 3x plus 12 because of the positive 4 and 8. That is what we need to multiply by. Now I can't do anything, can't combine 3x and 12, so I have to leave it like that. So when I plug this in, I'm just kind of aware, I'm going to have to distribute that 8 across to the 3 and the 12. What a lot of students are going to do, the number one mistake is they're just going to plug in 3x plus 12. They're going to forget to add and use the entire line segment. Well, good morning, Cameron. And we're going to set that equal to the other set. So we're going to do 7 on the outside, because that's the outside piece, times this whole piece right here. So I just want to think about what I would call this entire piece, which is 5x plus 2 plus 7, or 5x plus 9. And that is the algebraic setup. I mean, that is the hardest part of the problem, is what we just did, is the setup. I know you guys can do the rest. So everyone goes at their own pace, and that's fine. But I know you guys can all do the distribution, combine like terms, and anything from there. Because once you have it set up, it's very rare that someone would get it wrong. All right, distributing, we get 24x. Then we get 12 times 8, which is 96, equals 35x plus 63. Let's see, I'm going to put the 24x on the other side because there's a 35 over here. That'll just make it positive 11. And then I'm going to subtract 63 from both sides, which is going to give me 33. And that works out very nicely. Divide both sides by 11. We get x equals 3, which is the final answer. They don't want anything further. Nothing to plug in. All right. And that's all we're doing. So we're just going to keep practicing this rule. Some of them will get harder, but as long as you can do the setup, if you're comfortable with how I'm setting these up, you should be fine. All right, number 8, it says find YZ. So I'm actually just going to highlight what YZ is, so it's good to know what we need to plug into. So they want me to find this inside segment, which, if we remember, that's not part directly relatable to the rule. So, I mean, obviously we just need to figure out x and then plug back in. But the rule says it's this times the entire piece. And the entire piece is 15 plus x minus 1. So we can call the entire piece 15. 15 minus 1 is 14, so x plus 14. On the other side of that, we have 12. That's fine. And then this entire piece, well, it's 12 plus the x plus 8, or x plus 20. So sometimes it's good to just have everything labeled so you know what can get plugged in. Because basically everything I bracketed off, those are the things that get multiplied together. That highlighted piece doesn't actually get multiplied by anything. So my setup's going to look like this. 12 times the outside, the entire secant, which is x plus 20. We're going to set that equal to 15 times the whole outside piece, which is x plus 14. So we get 12x plus, it's 240, equals 15x. I think this is 210. 15 times 14. I think it's 210. Yeah, it is. It's 210. All right, same thing as before. I got 15x on the right-hand side, 12. So I'm going to bring the 12x over here. Subtract the 210. And we get 30 equals 3x. And then lastly, divide by 3. Well, not last, but we do have one more step. We are going to have to plug in. But that is going to be the value of x. And then we can just plug back in. So we want the highlighted portion, which is yz, which is 10 minus 1, right? X was 10, yep. So yz is 9. And then you can of course check your work. If x is 10, that makes this 18. You can see, does 12 times the entire piece, which would in this case would be 30, is 12 times 30 equal to 15 times that outside piece, which would be 24. Are these equal to each other? And I mean, I'm imagining that they are, but that's a good way to check your work. I can just do it really quickly. I get 360 on the left-hand side, and then 15 times 24, I get 360 as well. That 360 is completely independent of 360 degrees. That's more of a coincidence than anything. But it's a good way to check your work. So that is in fact our answer. Oh, this is the first time we're seeing one where we're going to actually we have a tangent now. We're assuming that anything that looks tangent is tangent. I'm pretty sure that said that in the directions. Yeah. Assume segments that appear to be tangent are tangent. So, this 24 looks tangent, so we're going to assume it's tangent, and then we have that 18 and x. So this rule is, the behavior for the secant part is exactly the same. Outside piece times the whole piece, which the whole piece is just 18 plus x, or x plus 18, doesn't matter. But when we have a tangent, we need to square it on that side of the equation. So the setup's going to be 18 times the entire thing, which is 18 plus x, equals, and the right-hand side is whatever the tangent is, which is 24, and then square it. That's it. So you could argue that this setup's even easier, but it doesn't really matter. You still need to remember that portion of the rule of outside piece times the entire thing. All right, so we get 18 times 18, which is going to be 324, plus 18x equals 24 squared, which is 576. We subtract 324 from both sides. Those cancel. We get 18x equals 252. And then we are just solving for x, so we just need, this is the last step, divide both sides by 18. We don't need to plug anything in. X is 252 divided by 18 is 14. I know I'm doing the arithmetic faster. I'm sure a lot of you guys need to plug it in the calculator. I don't think any of you are freehanding that. But if you are, awesome. But definitely have a calculator nearby. Alright, same idea. Except now we're going to be finding the value of Pn. So before I really begin, I'm going to do what I always do and highlight the thing that I'm looking for. So I know what I need to plug in for. So all I got to do is plug in for 5x minus 1 after I find the value of x. I'm going to bracket off the things that I need, which are 8. And then I want to write an expression for this outside piece. So it's 5x minus 1 plus 8. So it's fair to call it 5x plus 7. And that's 16, which looks tangent. We will assume it's tangent. So we know the other side of the equation is just going to be 16 squared. So we're ready for our setup. The outside piece, which is 8 times 5x plus 7, is equal to the tangent squared. What's the tangent? 16. So 16 squared. We're going to distribute. So we get 40x plus 56 equals 16 squared, which is 256. Subtract both sides by 56. That's nice and easy. And we get 40x equals 200. Nice easy answer for, or at least for the value of x. Divide both sides by 40. We get 5. So plugging in for Pn, 5 x is 5 minus 1, 25 minus 1, Pn equals 24. Hopefully so far so good. As far as the rule goes, the most important thing is you know how to do this setup. The only thing that's going to get harder from here on out is the algebra. That's it. Because now we're going to start seeing some x squares or maybe some quadratics and stuff like that. But that's not new. It's can you get the initial setup. So in all of these questions, if I highlight, can you get this on your own, this, and this. All those pieces I'm highlighting that's kind of the geometry of it, and that's what you are able to get. And if you're able to get that, you're in a good spot. Because now I think we're going to get into ones that I think algebraically are probably more challenging than you would probably normally see. But, obviously we could see it. But let's take a look. 11, solve for x, which is good. And x is a tangent, which means we need to square it. But now this is the first time we're squaring the variable rather than squaring a number. Let's look at the pieces that we need, which is 27. That's fine. And then, like usual, we're going to need to add these together and call that 48. So this actually works out pretty nicely because we have the outside piece, which is 27, and the whole segment, which is 48. There's nothing to distribute. We just got to multiply them together. And then the tangent squared, which is x squared. So this is actually pretty easy. 27 times 48. 27 times 48 is 1296. But that's equal to x squared. So to get x by itself, we're going to square root both sides. And the square root of 1296 should be 36. So, not too bad. Number 12. Same idea here. Only kind of curveball they throw at you, instead of labeling the side as... Can I go back to number 8? Yeah. In number 12, you're going to see that they label the tangent as 3x rather than x, and we're going to see how we are going to square that term. Once Ryan just wanted to see this one really quick. Once he's all set, I'll go back. Good with 8? Awesome. All right, so number 12. So we have this piece right here, which is 9. This entire piece, which we're calling 25. So initial setup, the two I bracketed off, 9 times 25. But now when you square 3x, a lot of students are going to write 3x squared. But you have to put the 3x in parentheses, and then you're going to square that. Every component gets squared because it's really 3 times x. So in a way you can think of it like distributing an exponent. I don't like kind of saying that, but that's kind of what happens. The 3 needs to be squared and the x needs to be squared. So when you're squaring 3x times 3x, because remember what a square means. It's 3x times 3x. And when you see it written like that, I think when you look at it like that, it becomes immediately obvious. Oh, 3 times 3 is 9. X times x is x squared. Because you do need to square both things. So it is going to be 9x squared. And then 9 times 25 is, I think that's 225. As we just established, squaring 3x becomes 3x squared. You have a few options from here. Some people will square root both sides, which is fine. It'll work. I like to divide both sides by 9, because square rooting both sides usually is only beneficial when that number happens to be a perfect square. So I'm just going to get rid of the 9. I want to get x squared by itself first. So I'm going to divide both sides by 9. And 225 divided by 9 is 25. Then I can square root both sides. And square rooting both sides gives me x is equal to 5. Actually, is that my answer? Yes, it is. Just making sure I didn't have to plug back in or anything like that. So like I said, the setup is fine, but you just want to avoid, because what a lot of people will write is and this is going to be an incorrect setup, so I'll write it in a different color. A lot of people would write this as the setup. They'll forget to put that 3x in parentheses, so this, don't do. That's kind of the algebra you want to avoid. That's why when in doubt, put terms in parentheses. Parentheses are very important. Number 13. All right, so now we actually go back to the very first rule. We haven't seen this one today. But this is the easier of the 3 rules, I think, because it's just this piece times this piece right here. But look at what you're multiplying together. One is labeled as x minus 1. The other one is labeled as x plus 6. We are multiplying 2 expressions together. So some of you are going to have to do that box method. Because when I'm writing it out, again, parentheses go a long way. They will purposely not use parentheses, but you are required to use them, especially when doing your initial plug-in. It needs to look like that. So you have 2 binomials multiplying together. You're going to have to FOIL, box method, whatever method you're comfortable with getting this. And just be aware that you have x's multiplying together. This is going to turn into a quadratic. So we are going to have to solve a quadratic, just like we were doing when we did that algebra review in practice just last week. The right-hand side, I think, is fine. Just 2 numbers, 2 relatively easy numbers, 12 and 10. Multiply them together. 12 times 10. No problems there. So make sure you give yourself enough room, because this problem can get a little bit longer. Because we have the box method or FOIL this. We're going to have to set it equal to 0. We're going to have to factor and figure out things from there. So there's a lot more to do with this problem. This one is definitely a little bit more advanced. I'm going to FOIL instead of box method. So I'm going to do x times x, which is x squared. X times 6, which is 6x. That's my first and outer, then the inner, which is negative 1 times x, so negative x. And then negative 1 times 6, which is negative 6. Equals the right-hand side, 12 times 10, which is 120. And then don't forget, don't get overwhelmed on what to do here. Just do what you would normally do. I'm going to combine like terms, especially here. But because of this x squared, and you have x terms, you have to identify that you have in front of you a quadratic. And our way of solving quadratics are set equal to 0. You're not going to be able to isolate x squared, so you need a completely different algebraic strategy when solving an equation that looks like this. The methods we used for the previous 6 and the previous 6 from yesterday you're not going to work because it's a quadratic. So I'm going to combine like terms. X squared plus 5x minus 6 equals 120, and I'm going to subtract 120 from both sides. So x squared plus 5x minus 126 is equal to 0. Then I want to start figuring out numbers that multiply into 126. Well, negative 126. That are going to add into positive 5. Again, I know I've mentioned this before. If you don't memorize how I do this, but if you see the signs, positive, negative, it's going to be two different signs. The bigger number is going to be positive. So you're going to have one big positive number. The other number is going to be negative. So just kind of plug in numbers. I think the factors are going to be 14 and 9. 14 and 9. And like I said, big one positive, smaller one negative. You just double check. Do those work for this scenario? 14 times negative 9. It's 126. Add it together, positive 5. So those are the correct ones. Remember, that step that I did right there, I did it a little quick because I can do these a little quicker, but that step might take you the most time. You know, you're probably going to have a calculator in front of you. You're going to be dividing numbers, figure out which ones are going to be there. Like I said, I'm able to do that very quickly. I'm making it look easy, but, that could take someone easily the most amount of time. That could take up to 5 minutes just kind of figuring out numbers because you might overlook some numbers and so forth because you got to kind of find all the multiples, stuff like that. But it's easiest just have a calculator, plug in numbers, and figure out which ones they're going to be. When in doubt, you can use that quadratic formula. You can use your negative b plus or minus square root b squared minus 4ac over 2a. You can, of course, always resort to that. It always works for quadratics. So our factors, x plus 14, x minus 9 equals 0. And then, setting equal to 0, we get two answers. We get x is equal to negative 14 and x is equal to 9. So we get two answers, but it's important, especially for a geometry problem, to check your answers. Now, we sometimes have a habit of just dismissing the negative answer, which I would say for 95% of problems that we do, which is going to be probably almost all of them, it's usually the negative answer that's no good. But you can have negative x values. You just can't have negative lengths when you plug in, because you can plug in negative numbers and get a positive result. That's fine. That would make negative 14 fine. But when we go back to the problem here, as soon as you plug in negative 14 plus 6, you get negative 8. We want to avoid negative lengths, so negative 14 will be the one that gets crossed off. Plugging in positive values will be fine. So we cross out negative 14. It is, even though it's an answer to the quadratic, it is not part of the solution to our geometry problem. So the only answer is positive 9. Definitely lengthier, but again, the only thing that's harder is the algebra. But it's all algebra you've learned last year, we've practiced this year, and so forth. Let's take a look at number 14. This one actually looks a lot easier. Maybe I'm wrong. I don't know. We'll see. So, the initial setup, outside piece, we have two secants times the entire piece. So that's easy. The entire piece is 6. So outside piece 4 times entire piece 6. Set that equal to, you're going to have the same thing on the other side. X for your outside piece times, that's x plus 5. So you are going to distribute an x. We're probably going to have another quadratic here. So x plus 5. So yeah, it looks like we are going to have another quadratic. That's fine. Left-hand side is going to be 24. We're going to distribute this x. So x times x is x squared. And then x times 5, which is 5x. Now, when you're solving for 0, in this case, we're going to have 0 on the left-hand side. Just because of the way I set up the problem, you always want this. It's always best to keep it positive. It's allowed to be negative, but I think it's easier just to keep it positive. So I'm going to subtract 24 from both sides. So the left-hand side is going to be 0, but we know it doesn't really matter where that is. Plus 5x minus 24. And this is going to be what I want to factor. Two numbers that multiply into negative 24. Two numbers that add into positive 5. I get the same scenario too. I have positive and negative, so it's going to be a big positive number and a small negative number. So we got to think of numbers that multiply into 24. A lot of numbers multiply into 24. Can't be 6 and 4. 8 and 3? I think it's 8 and 3. Bigger one positive, smaller one negative. Do they work? Yeah, those are it. So x plus 8, x minus 3, set it equal to 0. We have our two answers. We're going to have to flip those signs, setting equal to 0. We get x is equal to negative 8, and x is equal to positive 3. But double check, make sure you plug in x to make sure that you don't get any weird solutions. Because this side is just labeled as x, this is a case that the negative value just can't work. So negative 8 is not one of the solutions. So I'll cross off that one because it is not correct. Even if we subtracted 24, is it okay if we wrote the 0 on the right-hand side? Of course, yes. In fact, usually I actually do. I just didn't because I didn't want to confuse anyone. But Paige, that I actually do exactly that. So yes, that is completely fine. Good. So we're just going to be running some more quadratics. Looks like we got two more. All right, number 15. They're throwing some decimals at us, but that doesn't matter. We still got to treat the rule, you got to treat the rule exactly the same. So, unfortunately, the outside piece is 5.5. This one we add together, we will get a whole number. That's going to be 28, so that's fine. But we are multiplying that by 5.5. But you can't, just because they gave us decimals doesn't mean we can kind of change the rule to make it easier for ourselves. It's just what we have to do. Then the right-hand side is going to be x for the outside piece times the entire piece, which we're going to have an expression for x plus 15. So we're in a very similar boat that we were in the previous problem. We're going to be distributing an x across itself and a number. We're going to have another quadratic on our hands, most likely. That decimal, though, it can get, if we have a decimal as a b term or a c term, probably going to have to use a quadratic. But this might end up being a whole number. Let's see. What is 28 times 5.5? It's 154. That's good. That's good because this might allow us to factor. We're going to distribute x squared plus 15x. And then we will solve for 0. We want to get the 154 on the other hand side. And I'm going to do exactly what Paige suggested before. I'm going to just write it like this. Subtract 154 from both sides, but I'm also going to mentally flip my equation, just because I like it written like that. Oh, we keep getting the same thing. We keep getting a positive and negative. That's kind of nice. So we want to find two numbers that are going to multiply into 154, but then add, subtract into 15. So let's see. Trying to think if I can get these factors. I don't know if I know. So I'm going to take a calculator and just start dividing by certain values and see if I get anything significant. I'm not getting anything really. $11? It's 11 and 14. That doesn't work. Oh, I found them. 22 and 7. So sometimes they're just going to take a little bit more time to do it. And I know, unfortunately, you can't see what I'm doing. I have a calculator in front of me, and I keep just dividing by numbers to see if the result and the number I plugged in would subtract into 15. Yeah, actually, I can show you my screen. So literally what I'm doing is I'm just taking 154 and I keep dividing it by numbers. That's why I suggested 14 and 11. Because I did 154 divided by 14, I got 11. But I knew 14 plus 11 was 25 and 14 minus 11 is 3, so they couldn't be it. And I finally landed at 22 and I got 7. I don't know why I didn't do 7 first, but I got to 22 and then I realized, hey, 22 minus 7 is 15. And that means 22 times 7, or negative 7, whoops, is negative 154. So sometimes it just takes a little bit more practice getting the right numbers, especially with some of these, because I think we might be getting into some that you might have done, or a little bit more difficult than some of the ones you've seen last year. But like I said, if you can't figure out the factors, jump to your quadratic formula, because I was very close to doing that. But I was able to get it. So our factors are x plus 22 and x minus 7 is equal to 0. So our answers are x is equal to negative 22 and x is equal to 7. Obviously, our negative 22, because of that outside piece right here, can't be negative. We'll just cross off that negative right away and then just circle x is equal to 7. All right. We only have about a minute left, and I know these quadratic ones take a lot more time, so I know I'm going to go way over if I do number 16. Number 16 definitely is a quadratic because you're going to have to square x plus 5. And when you square x plus 5, you're going to have to do your box method to that and then figure out from there. Feel free to try it out on your own. I'll go over it on Thursday if you'd like. The next 2 pages are just practice. Feel free to practice it. I'll show the answer key on Thursday. I definitely recommend just trying out, maybe not all of them, but try out some of them. I'll go over any of them on Thursday at the beginning of the stream. Or I'll put up the answer key so you can look at what you got and then you can ask me questions. Because other than that, I'll put some of these on an assignment in the future. But these are definitely a good thing to practice because as far as things we've seen geometrically and algebraically, this is by far some of the most challenging. We've never seen anything algebraically as tough as this. And these rules they're a little weird. They're not the easiest to use, and they definitely require you to memorize them. So this is definitely something. If you practice it, you'll remember the rules better, and you'll kind of fine tune your algebraic skills. So if there's anything to practice, this is it. And you have today and all of tomorrow to do it. All right, but that does end our stream, and we are all set. No mistakes today. Yeah, and obviously today would be the day with mistakes because this was the harder stuff. I screw up the easy stuff apparently. But friends don't let friends confuse irony and coincidence. Huh. Mrs. Cooper. Interesting. You're welcome. Have a good one. I'll see you guys Thursday.